Hey folks, welcome back to another adventure in the garage. And for those of you that are new to the channel, my name is Luke, and today I'm going to be helping you with all of the test settings and functionality of the AstroAI DM2000. I just tried this thing out a little bit, and I'm actually pretty excited. I am a big fan of AstroAI, even though they are not an affiliate of the channel. I do like the functionality of their products for the price. It's a lot of bang for your buck. This meter has a little bit more advanced functionality, so it's going to be a little bit more in depth, so hang in there with me. I really want to go over this whole port section, and then I'll be giving examples as we go through all the different test settings. But a feature that is very cool that I've been seeing meters implement is when you go to a test setting, it will highlight the ports that you need to have your test leads plugged in for you. So that is very exciting, but it's still important that we understand all the lingo that they have going on down here so we can better understand our tool. That being said, let's go ahead and dive into what they're trying to communicate down here. Now, this is a True RMS meter. It's an acronym for root mean squared, and that's going to have to do with our AC, or alternating current, voltage and current measurements and their accuracy. So having a True RMS function on here is great. This square within a square means double insulated, and CE here is a certification, as well as our CAT certifications. CAT certifications are a lot more complicated than you would think. There's some information on fluke.com about CAT certifications and where they're applied. What they're trying to say here for this red port is they're trying to indicate that this port is for measuring voltage, ohms, Hertz, duty cycle, live voltage, thermocouple. It can measure capacitance, diodes, and is for continuity. This is the main port for the meter that you're going to be utilizing most of the time. This one's pretty straightforward. This is your COM port, or known as common. And then over here, this is where it gets a little funky. Some of you are used to mostly just 2 ports, maybe a third. This one has 4 ports. And then over here, what this is saying is that this is for measuring micro and milliamps. So for these 2 settings up here, and then this one is just for amperage, which will be that setting there. And all 3 ports are fused. That's what that symbol is indicating there. Excuse me, these 2 ports are fused, not all 3. Just these 2 ports are fused. And then it obviously is giving you information about the current and or voltage that those ports are rated for, such as this one, no more than 200 milliamps, or you'll blow this fuse. And then for our 10 amp is obviously rated for 10 amps at 250 volts. And so on. So that's a little skinny into all the nonsense that's going on down here. It can be a little intimidating, but again, they do have that light up function to indicate which ports you're supposed to be using, which I really love. It just makes testing so much easier. A couple of the features, we've got this antenna here for your non-contact voltage. So that's going to act as basically your hot stick. And then we have a backlight, a nice large display. And if we hold down this, we also have a little bit of a flashlight, which is pretty handy. And then our functionality, hold, min and max, all pretty standard stuff. Overall, I like it. It's kind of a chunky little meter. For the price though, and the amount of functions that you get, again, not a sponsor, but you just can't beat AstroAI when it comes to that stuff. 2, in quality. I will say I've tested a number of their meters on the channel, and I've never had any quality control issues with their products so far. Exactly as advertised, which is not always the case with every meter. You would be really surprised when you start going in there and testing every single function of the meter and its accuracy. It doesn't always pan out that way, but we're just going to start from the opposition, and we'll work our way clockwise, starting with our voltage setting. Something that you're also going to notice on your display wheel, and this is kind of a newer function that some of these meter manufacturers are pushing, and that's this. I don't know if I'm going to get it to focus. It's really hard to see. I wish they wouldn't have used red, but basically it stands for Hertz. It's an HZ, Hotel Zebra, and you're going to see that marked all over the meter. And this is something that's really cool that these guys have been doing not just AstroAI, but other meter manufacturers, is when you're in an AC measurement function, now you're going to see two numbers displayed. And Hertz is going to be available to you anytime you're measuring AC voltage or current, which is not necessary, very much overkill, but I think a great little touch. I do really like a secondary small display up here for especially functions like your thermocouple, where it's going to display in Celsius and Fahrenheit at all times, so you don't have to cycle through windows to have your preferred unit of measurement, which is nice. So you're gonna see that Hertz labeled on here a bunch of different times, and basically that's just saying anything where you're working with alternating current that we can see is indicated here. It'll have that Hertz at the top. We'll go ahead and start with voltage DC. Now, voltage DC, your lead polarity is going to be important. Let's do something simple. We'll just do a battery. Your lead polarity is going to be important to pay attention to. So what do I mean by that? So if we're going to measure something like a battery, we have two poles, right? A negative and a positive. When you think of your test leads, very same. Your black is the negative and red is the positive when we're making DC measurements, okay? If I want to measure DC voltage, red to positive, black to negative, and you'll see I get a nice strong 9.58 volts. That's great. What happens if you do it backwards? Well, it's not really a big deal. You're not going to mess anything up, but you are going to get a negative sign displayed on your meter here. And that just means that the flow is in the opposite direction of what the meter is expecting to measure. So that can be really confusing if you're new to testing, especially if you're not working specifically with negative DC voltages. But that's what that negative sign is indicating. The flow is backwards, so your lead polarity could be swapped, or the polarity of your circuit could be swapped unless you're working with negative voltages. So I hope that makes sense. And then we can go ahead and cycle to our AC voltage measurement. Taking an AC voltage measurement, our lead polarity does not matter because our voltage and our current is cycling back and forth, the polarity of it. So you don't have to do red to hot, black to neutral. It can be considered best practice, but it's not necessary. Now there's another feature on this meter. This feature is becoming more common. It's something that I really like. Notice how our display went to an amber color. Now it's gonna do that right around the 80 volt mark. So see, when I drop below 80 volts, that display goes back to that nice blue. We pass 80 and it gets amber, which I really like. Letting you know, hey, because to some people this is considered high voltage. In some applications to, depends on the scenario, but to some people that's starting to get into high voltage territory. But just a great feature. And then the next setting is going to be essentially the same, except it's specific to the unit of millivolts. So a very small amount of voltage. And let me see if I can just bring up, see, I'm going to output about 50 millivolts. Let's see what the meter picks up. Okay, 32 millivolts. So there is some voltage drop across my circuit because it is such a small amount of voltage. But I think that's a really great setting. This meter is like really versatile for the price. To have millivolts and microamp settings, a 4-port meter for the, I don't remember the price. It's like $30. It's insane. I don't know how they do it, but it's great. Okay, next is going to be Hertz and duty cycle. And duty cycle is going to be expressed as a percentage in the top of our screen. And Hertz is going to be this main display here, kind of like what we talked about earlier, as a function of whenever you're making those. Let's see, I didn't even check. Yeah. So like when we were doing our voltage AC, we can see our Hertz displayed up here. And then when we go to our Hertz setting, now Hertz is the main display. And we're just going to talk about Hertz and duty cycle here for a second to help kind of clear it up in case you're confused about the two. Hertz is the amount of times something oscillates or turns on and off per 1 second. So here in the US, our AC voltage coming out the wall is at 60 Hertz. I believe that's just North America in general. The rest of the world, it's at 50 Hertz. So that means that the waveform of the AC is cycling back and forth 50 times per second, okay? If you have something like a square wave that this little meter can put out, not only are we going to be able to measure how many times it turns on and off per second, but the amount of time that it's in the on position relative to the off position per second. So if I take a measurement of the square wave output of this other AstroAI meter that I have, man, they've come a long way, huh? We have a 50 and a 47. What does it mean? Well, the 50% means that it's on 50% of the time and off 50% of the time. And then our 47 Hertz means that it does that 47 times per second. So that can be a really handy little setting. Again, I love this dual display because on most meters that have a functionality of Hertz and duty cycle, you would have to cycle through the functionality to give you one or the other. And if you're looking at data that's moving around a bit, that can be really frustrating. So having them both is a really nice function. I've been a fan of it. K-Wheats, who is an affiliate, they do it as well. And the first time I saw it, I just thought it was the coolest thing. Okay, so this up next, keep in mind, we're still in just these first two ports here. You're gonna be red lead in this port most of the time for most of your measurements. So this section is going to be your resistance, continuity, and diode. It's gonna default to resistive measurements. I've got some resistors here. And it's auto ranging, which I love. The last couple meter videos I made were on manual ranging meters, and I'm getting so sick of them. So it's been really nice. Something that we want to pay attention to when we're making our resistive measurements is there's going to be, we want to look for an M and a K or nothing next to our horseshoe or our omega symbol, which we use to represent resistance. This is 1 mega ohms instead of just 1 ohm, okay? So 1 mega ohms, we're utilizing the metric system here, which for us here in the US is not very common, so a lot of us are not familiar at all with it, but think of mega as 1 million. So this is telling us it's reading a value of 1,037,038,900, or, you know, you get the idea. That's something that we want to pay attention to as I move on to another resistor. Okay, now we just saw that it changed to a K. So K ohms, so 9.977 K ohms. K is kilo, or think of thousand. So what this is trying to say is that this is 9,976 ohms, okay? And then if we don't see anything there, then it's just, it is what it is. This is just 99 ohms. That's pretty cool. And then continuity, for those of you that are not too familiar with the continuity function and what it can be good for, continuity is great for just sorting out which wire goes where, especially if you've got a bundle of wires and you're trying to figure it out, like if you're doing some kind of automotive wiring or whatever, and you want to figure out who's who, where's where, what's what. Like an example here. Okay, nothing there. Okay. And then we have a light at the top to indicate continuity too. And we'll have an audible tone, which is great. It's letting us know the black wire goes to here and the red wire doesn't go to here, but it goes to there. So it can be handy for sorting out a lot of different wires. It makes a tone, which is nice because if you're in a bundle and you're trying to do these measurements, it's nice that you don't have to look at the meter for your results. You can just listen to see where there's continuity. And then the added light at the top is something that I really like because at a glance, it's just letting you know, yes, there is continuity there. Great function. I'm so impressed with this thing. Like, okay, and then next, that little arrow there, that's our diode symbol. We'll go ahead and do a test here. Diodes, we always want to test in both directions. What value we're reading on the meter there, that is our voltage drop. Now that's a whole nother subject and video. I'm sure there's plenty of great ones out there. I'll try to make one myself here soon. what we could do here. Press the hold button. So that's what you utilize the hold function for. It holds the value of whatever you're trying to measure so you don't have to keep your leads on there. So you could write it down or whatever. What are we looking at here though? So this is the voltage drop across the diode. And what we ideally would like to see for just a standard diode is somewhere between 500 and 800 millivolts of voltage drop. Now I'm reading 562 millivolts of voltage drop. So I'm within that range. So in this direction, it's good. But with diodes, we always want to measure in both directions so that to ensure that there's no backflow. So I should, the OL should stay on the screen as I make this measurement, indicating that there's no flow in the other direction. And that means that this diode is good. Another little thing I always like to do when testing the diode functionality is to measure a white LED and see if it can light it up. And it can. Sometimes what it'll do is it'll display the voltage that it's needing to light up the diode. And that's known as your forward voltage, the voltage it needs to be able to chooch. Doesn't display it, but it does light up the white LED. So that's pretty cool. I'll take it. Okay. And then next up we have capacitance. We always want to make sure that our capacitors are discharged no matter what meter. Doesn't matter the brand or anything like that. Always make sure it's discharged before you hook it up to your meter so that you do not damage your meter. And for this little guy, we have a negative sign indicating black. Some people will really freak out if you do not put the black lead to the negative sign. It's going to take a minute. The meter itself is going to charge the capacitor and then it's going to measure the capacitance of it. So it's going to take a minute for it to charge up and then we'll be able to get its value. $629 millifarads. I think what that's trying to indicate is microfarads, not millifarads, because millifarads would be an incredible amount of capacitance. So that is a little confusing that it's annotating that with an M for mic, a lowercase mic symbol, because that's standard for milli, not micro. But that's what they gave us. So something to pay attention to when you're measuring your capacitance. But there you go. It still has the function. That's really great. All right, on to something a little more exciting. This one's pretty straightforward. This is the thermocouple application. What is it good for? I don't like this style of lead that they have, but it's getting more and more common, especially for these lower end meters. They're just really delicate. So they're really, really common. They're really delicate no matter what manufacturer you're buying from. So whenever you're removing them, be super careful. Let's go ahead. We've got our Fahrenheit and Celsius values. It's indicating here that those are the ports that we need to plug into. And then something I always like to do is grab it with my fingers and make sure that my thermocouple lead is actually working before I go and apply it to something that I'm actually trying to make a measurement with. Some of you might not be familiar with the thermocouple lead. Basically, it's like you can place it or tape it or whatever, fixate it to, maybe something that gets really hot before it gets really hot, obviously, so you don't burn yourself. You can put it on there and it'll really accurately measure the temperature. And then it should have in the owner's manual what it's rated up to. I believe probably at least a few hundred degrees. And it'll do so incredibly accurately. It's great for like HVAC work. You can use it for automotive applications, anything where you're dealing with very cold and very hot temperatures and you need accurate measurements. It's a great tool. So hope that makes sense. Now we're going to be having some fun. We're going to be changing it up a little bit. We're going to be moving over to the microamp setting. It's going to let us know, it just flashed what we need to plug our leads into. And just a quick note with that, I did notice my meter, I've never seen this before. It came with batteries pre-installed in it. And I noticed when it was in that initial setting where these green LEDs are blinking, I was seeing the backlight dim, indicating like a voltage drop. It was just weak batteries. So I just threw some fresh batteries in there and that cleared it up and everything looks great. So we want to be really careful that we're not measuring things for this port that are above 200 milliamps. I know all of my loads here are less than that. So I just want to go ahead and give you an example of what this looks like. This can be a little bit confusing. Something that it does have also is you have your AC microamps, which is just super stellar. We're just going to be focused on DC measurements for right now. But you want to make your measurements in series with the circuit. That's my smallest load. That is saying I'm measuring at 1,194 microamps. Very cool. Then I can go ahead and cycle it down. Now we're at 12 milliamps, and it's giving us to the 1,000th, which is just so cool. And then what do we have here? This is about 120 milliamps. So I'm getting closer to that 200 milliamp limit that's annotated on the meter. So I got to be careful of that, but super cool. And then let's have some fun with some larger current loads. And again, this measurement is done in series as opposed to parallel. Something that's important that you'll want to learn in your electronic testing journey. Something I put off for way too long, but let's see here. We'll do a little output. Okay, so I'm gonna be measuring some larger currents. I'm gonna swap this over to just the amperage setting. It's gonna let me know, hey, move this port lead up to here. Thanks, meter, for the reminder. Super cool. It also has, for measuring current, for AC circuits, up to 10 amps. And then it should say in the manual, but usually if you are measuring something up to 10 amps with your meter, which is kind of insane, it's generally going to be no more than like 10, 15 seconds or something like that. It should be in the manual, but it doesn't mean you can just indefinitely, hook this in series to your circuit and it's rated to carry 10 amps of current at all times. That's going to barbecue your meter. So don't do that. But we can go ahead and just do these in series. We've got a little motor here. Now, polarity when measuring current for DC can matter. It's just like measuring voltage. You can see that negative sign comes up when I do it in the other direction. And then we could do it for the light bulb. And then notice there's going to be a current threshold. I don't know how much current. I wonder if I can drop the voltage and that should lower the current, and then we can see at what point. Is it more than 1 amp? I don't know. I'm starving this bulb for voltage. Okay, so anything more than 1 amp, it's going to light up for that amber display. Super cool detail. I love that one. Okay, and next is going to be your non-contact voltage and your live. And this is pretty slick what they do here. Now, I personally am not a fan of just the non-contact voltage setting. I'm not a fan of just the non-contact voltage setting, but it's available to us. That should be what it defaults to, which it does. Non-contact voltage. You can go ahead and get some voltage going on here. And in this setting, it should be pretty straightforward. Now, it's not as slim as a hot stick. It's a bit bulky. So trying to get it into a tight spot, it's not going to really work out very well. But what we can do, hit our function button. We go live. We only need one test lead for this in this port. Boom. And then we can do it very accurately and in tight spots. And they can just let me know. Dang it. It was so close. I had this happen on another meter too, where the live function didn't work as intended or as advertised. Dang it. Okay, that happened on another one. Basically, what's supposed to happen, maybe this is just a defected one. I kind of doubt it, but maybe it is. The way the live function works is you could just take your lead and press it to a live terminal, and then it should illuminate and let you know what's going on there. Okay, well, it kind of works with the non-contact voltage setting. Okay, I guess you could do it like that. The way it's intended is when you do it live, and then you do like this, but I guess this works too. So then the H is obviously for high voltage. The L is for low. Anyways, there you go. It's AstroAI DM2000. I would recommend this meter. I don't have like a meter ranking score yet, but maybe something I should look into. Man, I think this meter would be great for really just about anybody, for any kind of application where you would need a multimeter. If you have any questions, comments, or concerns, please let me know down in the comment section. I try to respond to everybody. Go ahead and check out my link tree. Like and subscribe if this video was helpful. If not, give me a thumbs down. You know, I always appreciate the feedback. Anyways, thank you for joining me in another adventure in the garage, and I'll check you on the next one.